Hello everybody in grade 10. Today we are doing a video about solving linear equations by graphing. So you actually did learn this concept in grade 9, but we are revisiting it today. So hopefully you remember how to graph lines, and this should be a review for you. Okay, so solving linear systems by graphing can be very helpful in word problems. And later on in this unit, when we focus just on word problems, I'll be showing you much more difficult graphing examples. So today is just meant to be showing the basics. So our learning goals are that we will solve a linear system by graphing and define the solution to a linear system, and then verify that our solution is correct. The thing with graphing is that we're never quite sure if it's exact unless we test the algebra. So here is a linear system. You have two variables, x and y, and two equations that are both linear equations. You know that they're linear because there's no variable or exponent, higher than 1. So if we were to rearrange this equation into y equals mx plus b form, we would just move the x to the other side. So we would get y equals negative x plus 3. Okay, so notice that it has a slope of -1 and a y-intercept of 3. If we are to rearrange the second equation, we would get -2y equals -x. And then from there, we would get y is equal to 1/2 x after we divide both sides by -2. -1 divided by -2 is positive 1/2. So to solve this system, we want to find the x and the y. The x and the y that work in both equations. So one way to do this is by graphing. So let me find here. Different color. Okay. So this first equation, negative x plus 3. So we would plot the y-intercept at 1, 2, 3. And then our slope is 1. So we'd go -1, So down 1 over 1. Down 1 over 1. Down 1 over 1. Down 1 over 1. Okay. And I thought I had a line tool, but I can't find it. So you should use a ruler to do this and not be disgustingly awful like my awful line. Well, this is so bad, guys. Bad example, Mrs. Weens. Okay, there's my line, kind of. So that's y equals -x plus 3, looking pretty nasty. And okay, let's do some purple. Let's do it a bit thicker here. Okay, so this one is 1/2 x. So it has a y-intercept of 0, 0. And then I go up 1 over 2. Up 1 over 2. Up 1 over 2. Okay, down 1, left 2. So this line, it's my other line. Again, use a ruler, people. Okay, so my point of intersection is my solution right here. And you can see that that is 2, 1. So the lines intersect at 2, 1. So that means that the point 2, 1 is on both lines. So that means that if I put x equals 2 and y equals 1, that will work in both equations. So that will satisfy both equations. Let's go on to the next example. Here are the equations for two lines listed below. What are the coordinates of the point of intersection? So the first thing we want to do is change into y equals mx plus b form so that we can graph. Okay, so let's do that here. So if I move the x over, I get -y equals -x minus 1. And then I want to divide everything by -1 so that y is alone. So then I get y equals x plus 1. Okay, so for this one, I again move the 2x over. I would have negative y equals negative 2x plus 2. Divide everything by negative 1, and you have y equals 2x minus 2. Okay, so let's graph this one first, x plus 1. So I have a y-intercept of 1, and I go up 1 over 1, up 1 over 1. Okay, so obviously I don't have to do this many points, but it does help to see right where they intersect often. And also, I don't have a ruler right now on my trackpad, so it's easier to do it this way. Again, you should use a ruler. So that's x minus y equals negative 1. Okay, and let me do the other one now. I can do purple. Who doesn't love a nice purple? All right, so y equals 2x minus 2. So I have a y-intercept of negative 2 and a slope of 2. So I go up 2 over 1, up 2 over 1, up 2 over 1, bam, bam, bam. You notice that I already know where the y-intercept is. So again, I can connect the dots here with a ruler. Okay, and label it with the equation. Okay, and then I can identify the point of intersection, which is the solution. Okay, my x value is 1, 2, 3, and my y value is 1, 2, 3, 4. So that is the coordinate 3, 4. So 3, 4 is the solution to this linear system. Okay, so let's check now that that actually does work in both equations. Okay, so now we want to verify. All right, so we start with x minus y equals negative 1. Notice I am using the original equation and not my rearranged equation. Now, why do you think that is? It's because what if I made a mistake in rearranging it? I want to be able to find that mistake. Okay, so I put my left side and I sub in 3 for x and 4 for y. So 3 minus 4 is negative 1. So notice now that my left side equals my right side. So far, so good. Now I want to try it with the other one. With 2x minus y equals 2. So my left side of this equation is 2x minus y. And my right side is 2. So now I sub in my 3. So 2 times 3 minus 4 is 6 minus 4, which is 2. So my left side equals my right side. So the coordinate 3, 4 satisfies both equations. It works in both equations. So that's how I know that it is the solution to this linear system. Okay, let's do a real world example here with Stuart. Who doesn't love a good Stuart? Okay, Stuart wants to rent a small truck for moving day, just one day. So rent a truck charges $80 a day, so 80 bucks, and then 22 cents a kilometer. And Tony's truck charges $100 a day and 12 cents a kilometer. So which company should Stuart choose? So step 1 is to identify variables. Okay, so what do we not know? We know that moving is only one day. So day is not a variable. This is very important to understand. The number of days is not variable. It's not changing. We know it's just one day. However, we don't know the number of kilometers. So we'll say let D represent distance in kilometers. And then we can say let C, capital C, represent total cost in dollars. Okay, so now our next step is to create a linear system. Okay, so two equations using these two variables. So rent a truck, its cost is equal to, well, it's $80 plus 0.22 times the distance. Okay, and then Tony's trucks, its cost is $100 plus 12 cents times D. Okay, now our third step is to solve this graphically. Now, let me just put some of that. Okay, so we want our distance to be on this axis and our cost to be here. So we're going to solve by graphing. Now, let's think about this logically. If you're moving, you're not likely going just 1 kilometer, okay? So we're going to be going up by 20s here. So part of solving word problems is thinking logically about how many, like what your scale should be. Does it make sense to go up by ones, by tens, by hundreds, by thousands? And I happen to know the solution to this system, so I know that it's good to go up by 20s. So I'm going to label every other one. So that's 40, 80, 120, 160, 200. So notice how I don't label every single one. I label every other one. That just makes it less crowded. And then here I go up by 20s as well on this scale. So this is 20 and then 40, 60, 80, 100, 120, 140, 160, and then 180, 200. Now, on the other graph on the previous page, we just labeled the y-intercept and then used slope to find the next point. In this case, it doesn't make sense to do that, to go over 1 kilometer and up 22 cents, for example. That's really, really hard to do accurately. I would say almost impossible. So what's going to make more sense for us is that we do a table of values for each, for Rent-A-Truck, and then a table of values for Tony's trucks. Now, one of them is going to, so we'll have D and C. So you put your independent variable first, your distance, and then your dependent variable second. So we want to start at a distance of 0 kilometers. So at 0 kilometers, the cost for Rent-A-Truck is 80, and the cost for Tony's trucks is 100. So notice at this point, the cost of Rent-A-Truck is less than the cost of Tony's trucks. So what we're trying to do is find the spot where it's the exact same price. So what's going to happen is that eventually Tony's trucks will be less expensive and Rent-A-Truck will be more expensive. So if we get to a point where Rent-A-Truck is more expensive, we know that that crossover has happened. We know we've passed the point of intersection. So pay attention to that. So let's just sub in 80 kilometers. Okay, so you would put it into the equation, 80 plus 0.22 times 80. That gives you $97.60 for Rent-A-Truck, and 80 kilometers for Tony Trucks gives you $109.60. So notice Rent-A-Truck's still cheaper, but not by as much. So then I put in 160. Okay, and for Rent-A-Truck, I get 115.2. And for Tony's trucks, I get 119.2. So notice Tony Trucks is still more expensive, but they're very close in price. So that is, we're getting closer to where they intersect. So let's say, leave a blank here. Let's say I decided to get a bit more aggressive and go up to 240 for each. So if I put 240 in for this equation, I get $132.80. And for Tony's trucks, I put it in 100 plus 0.12 times 240. I get $128.80. So notice that the changeover has happened. So it has to be somewhere in here. So I'm going to try 200 kilometers for both. And when I put that in, I get exactly $124 for either company. So ding, 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 you actually found the solution because for 200 kilometers, it doesn't matter if you choose Tony's Trucks or Rented Trucks, it's the exact same price. So let's go ahead and graph these. So let's do Rented Truck first. So it starts at $80. And it's a little hard to show all these coordinates. So I'm just going to go right to 200 and try to do 124. So here's 120. So about a quarter of the way up is 124. It starts at 80. So again, you should use a ruler to do this. Oh boy, that's awful. There, that's better. Okay, a ruler will make a big difference. Okay, and okay. Now let's do Tony's Truck, a different color. So it started at 100, but we also know that it goes through this 200. I don't know why that dot disappeared. Okay. So this is where it's going to cross over. Again, a ruler is like just a wonderful thing here. Okay, so you can label this TT for Tony's Trucks, and you can label this RIT for Rent-A-Truck, okay? In real world examples, you don't actually have to use the equations. It makes more sense in this case to label it with each company. So what does this mean? This means we can label this 200, 124. What do we want to do? So how do you know which company to choose when? So less than 200 kilometers, notice that Rent-A-Truck is lower down. So that means it's less expensive. And after 200 kilometers, Tony's Trucks is lower down. So that means it's less expensive. So you can say if you're driving less than 200 kilometers, Rent-A-Truck is cheaper, and greater than 200 kilometers. Oh, my head is probably covering this, isn't it? Then you would say Tony's Trucks is cheaper. Okay, and then you can say if you're driving exactly 200 kilometers, both are the same price. Okay, so that is useful interpretation of the problem. Now, step 4 is to verify your solution, but because you already did the table of values, you basically already did it, but that would be step 4. And if you're doing an assignment or something longer for me, you should actually take the time to verify your solution so you can get those full marks. All right, so that is solving using graphing. Thanks for watching. Hope you learned lots.